On this program, a wide variety of rigging equipment is shown in many different situations. The particular equipment used in various rigging operations is often a matter of company policy. For example, some plants may require safety latches on hooks. Others may require the use of thimbles in the eyes of rope slings. Be certain that you understand and follow the rules in force at your facility.
There are four kinds of hitches commonly used for rigging: the vertical hitch, the bridle hitch, the basket hitch, and the choker hitch. The kind used to perform a lift is normally determined by the load. If the load has adequate attachment points, you will probably use either a vertical hitch or a bridle hitch. If you cannot attach a sling directly to the load, you will probably use either a basket hitch or a choker hitch. Now, in order to use these hitches correctly and safely, there are some procedures you must follow. To begin with, no matter what kind of hitch you use, you have to know how much the load weighs. You must be certain that it is within the rated capacity of the hoist and rigging equipment. The weight may be marked on the load, or you may find it listed on a bill of lading. If not, check to see if there is any information on file, a diagram or spec sheet that lists the load weight. If you cannot find the weight, you're going to have to calculate it by multiplying the volume of the load in cubic feet times the weight per cubic foot of the material. You can find the weight per cubic foot of many common materials in the employee's guide that comes with this program. To find the volume of the load, you measure it and then use the correct mathematical formula. If the load is rectangular, that's pretty easy to do. Just multiply the length by the width by the height in feet to find out how many cubic feet you have. For example, a 4-foot by 4-foot by 6-foot load contains 96 cubic feet. If the load is aluminum, which weighs 165 pounds per cubic foot, the weight of the load is 96 times 165, or 15,840 pounds, almost 8 tons. You can find the formulas for calculating the volumes of other shapes, like cylinders and hollow cylinders, in your employee's guide. If a load has an odd shape, you may have to mentally divide it into two shapes and add their weights together. Or if the shape is very irregular, you might imagine a rectangle that would completely enclose it and calculate the volume based on the rectangle. Whenever you cannot actually measure a load and must estimate its size, always overestimate. Once you know the weight of the load, you need to be sure that the load capacities of the hoist and rigging equipment are adequate. Hooks must be stamped with their rated capacity. Shackles, turnbuckles, and other hardware may or may not be stamped with a rated capacity. To check their capacity, you may have to refer to a table provided by the manufacturer. Synthetic web, metal mesh, and chain slings must have a tag that states their load capacity. But wire rope slings may or may not be tagged. Tables of rated capacity for various types of rope are available from manufacturers, government agencies, and professional organizations. This table is for 6 by 19 or 6 by 37 XIP IWRC slings. Note that for each diameter of rope, different capacities are listed for different kinds of end fittings. For example, under vertical hitches, this column labeled MS gives the rated capacities for ropes with mechanical splice eyes. The S over this column stands for sockets, swaged, zinc-poured, or resin. These capacities are slightly higher because sockets are rated as more efficient than mechanical splices. You might also find a column labeled HT for hand-tucked eye splices. These splices are rated at a lower capacity than sockets or mechanical splice eyes. The table also shows that the rated capacity of any particular sling will vary depending upon the kind of hitch being used. Let's see why this occurs. In a vertical hitch, the sling is straight up and down. and the angle formed between the sling and the load angle, is 90 degrees. As a result, the force on the sling will be equal to the weight of the load pulling straight down on it. So if the load weighs 5,000 pounds, you'd need a sling rated for at least 2.5 tons. If the sling has swaged socket end fittings, a 9/16" rope would be required. If the same evenly distributed load is lifted with 2 vertical hitches, each leg will carry half the load, or 2,500 pounds. So each sling would have to be rated for at least 1¼ tons, and a 3/8" rope will do. Now notice that when the same sling is used in a vertical basket hitch, its load capacity is almost doubled. The 3/8" rope will carry just over 2½ tons. That's because in a basket hitch, one sling creates 2 vertical legs, each one bearing half the load. The vertical basket hitch is the equivalent of 2 vertical hitches. But it is very important to remember that this doubling of capacity applies only when the legs of the sling form 90-degree load angles. If the load angle decreases, the capacity of the sling will also decrease. We've rigged up a demonstration to show you what happens when we pick up this 20-pound weight using a vertical hitch. As you might expect, the scale registers 20 pounds. If we use 2 vertical hitches, each leg carries half the weight of the load, so each scale reads 10 pounds. The same thing would happen if we were using a vertical basket hitch. But watch what happens when we create a bridle hitch by attaching both legs to a single hook. Even though the load still weighs 20 pounds, each scale now reads more than 10 pounds, because we've decreased the angle between the sling and the load to less than 90 degrees. Each leg of the sling now bears the additional stress of a side pull. In effect, the sling is having to support a heavier load. The amount of extra force that is put on the sling can be calculated pretty easily. This is a table of load angle factors. Each size of load angle has a corresponding load angle factor. For any load angle, to calculate the effective load on the sling, you multiply the weight of the load times the load angle factor. With a load angle of 60 degrees, for example, a sling has to be able to lift 1.155 times the weight of the load. So that means that for a 2.5-ton load, if the 2 legs of a bridle hitch create a 60-degree load angle, each leg will have to be rated for 1¼ tons multiplied by 1.155, the load angle factor for 60 degrees. Each sling should have a rated capacity of 1.4 tons. When you check the table of rated capacities for socket end fittings, you find that a 7/16" wire rope sling is required. Whenever you have a bridle hitch with 2 or more legs attached to a single hoist hook, you must account for the load angle. This is also true for a basket hitch, in which the legs are not vertical. You have to adjust the rated capacity for the angle between the legs and the load. When a sling is used in a choker hitch, its rated capacity is affected in a similar way. As the sling forms a loop around the load, it creates a load angle that is normally about 45 degrees. To determine the size rope required to rig a load in a choker hitch, you would multiply the weight of the load times the load angle factor for 45 degrees, 1.414. If the load weighed 2 tons, the sling would need a rated capacity of about 2.8 tons. If you look in the column for choker hitches, you'll see that the calculation has already been done. The table shows that a 9/16" rope will carry 2.2 tons in a choker hitch. Load ratings for choker hitches are always based on a load angle of 45 degrees or greater. That is why it is important not to force the choker down into a tighter loop. If you do, you'll make the load angle smaller and further decrease the lifting capacity of the sling. Now, anytime you rig an unfamiliar load and the sling is at less than a 90-degree angle, You're going to have to begin by estimating the load angle. This is done by drawing an imaginary line from where the sling will be on the load to where the hook will be when the load is lifted. Then, you can visualize the load angle pretty accurately if you remember that a diagonal drawn from one corner of a square to the opposite corner creates a 45-degree angle. And a triangle with sides all the same length forms 60-degree angles. Estimate the load angle by comparing it to either of these angles. In this case, it would be about 55 degrees. Based on your estimate, perform your load calculations. Select the appropriate slings, rig the load, and then look at the angle again when the slings are taut. If you have any doubt about your estimate of the load angle, particularly if it seems to be less than 45 degrees, measure the angle. When the angle is small, a difference of only a few degrees can make a significant difference in lifting capacity. And whenever the sling will bear a load that is very close to its rated capacity, make sure you've got the load angle right. Don't take any chances. Now, sometimes a load will require the use of 2 choker hitches or 2 basket hitches. Let's see how to calculate sling requirements for these situations. With choker hitches, you have to consider the effect of the choker and the effect of the load angles. Suppose you're lifting a 6,000-pound load with choker hitches rigged at a 55-degree angle. First, you adjust for the load angle. Each sling would bear 1.5 tons in a vertical hitch. So you multiply 1.5 tons times 1.221, the load angle factor for 55 degrees. You need slings that will support 1.83 tons each. Then, you check a load rating table for the size sling required to lift 1.83 tons. Assuming the slings are mechanical splice, find the weight in the MS column for choker hitches. Then read across to the sling size column. You need a 9/16-inch sling. Now suppose the same size load is rigged with 2 basket hitches attached to a single hoist hook. 2 different load angles are formed, here and here. All you need to do is account for the most severe angle. If this angle is 75 degrees and this one is 60 degrees, you would calculate the sling size based on the 60-degree angle. Multiply 1.5 tons by 1.155, the load angle factor for a 60-degree angle, and you'll find that each sling has to be able to support 1.73 tons. Assume you have mechanical splice slings again. Look in the load rating table for the size MS sling required to lift 1.73 tons in a vertical basket hitch. Whenever you do not find the exact weight on the chart, go to the next higher weight. Even when it is as close as the difference between 1.7 and 1.73, use the next largest size sling, 3/8-inch rope. Now we've seen that for hitches using 2 slings, you can figure that each leg will lift half of a balanced load. So you might suppose that with a 3-leg hitch, each leg carries 1/3 of the load. And with a 4-leg hitch, each leg carries 1/4 of the load. But actually, when the load is moved, one of the legs does not carry its share of the load weight. It is serving to balance the load. With a 4-leg sling, sometimes only 2 legs may be supporting most of the load, and you cannot tell which legs will bear the load. During a lift, the legs often change roles, shifting from balancing the load to bearing its weight. So, if you are using a 3- or 4-leg bridle hitch, figure the sling size as if you had a 2-leg sling. A 2.5-ton load with 60-degree load angles requires 7/16-inch rope slings, even if a 4-leg bridle is being used. Now, as we'll see, maintaining load balance is important, no matter what kind of hitch you are using. But when rigging an off-balance load, there are some important things you need to remember. An off-balance load is more likely to shift or wobble as it is lifted. There's a very good chance that the rigging will be under more stress than it would be with a regular centered load. So slings and hardware must be stronger. In fact, when rigging an off-balance load, slings should have twice the load capacity required for a balanced load. When you are using a bridle hitch, each leg must be able to support the entire load. And even then, you must rig the load to minimize the chances that it could shift. You do that by making sure that the load's center of gravity, the part of the load where the weight is concentrated, is directly under the hoist hook. If it is not, the load will tip until the center of gravity is directly under the load. For any regularly shaped load, the hook should almost always be above the center of the load, because that is where the center of gravity is. But in an off-balance load, the center of gravity will be off-center, in the direction of the heaviest part of the load. How far off-center, side to side and front to back, the hook will have to be placed will depend on how unbalanced the load is. The correct hook position will be somewhere between the physical center of the load and the heaviest part of the load. Make your best estimate and position the hoist hook. Then select the proper length slings to maintain this hook position during the lift. When the sling is in place, lift the load just off the ground and check to see if it is stable. If it tips more than 5 degrees, set it down, shorten or lengthen legs as necessary to change the position of the hook, and test it again. Do not begin to move the load until you are sure it is stable. All right, now let's take a look at a few other very important points to remember when using various kinds of slings and hitches. First of all, remember that any load lifted with any hitch should be rigged to stay balanced. Single choker, basket, and vertical hitches should be placed at the center of gravity of the load to minimize the chances of the load tipping. Whenever you are using a choker hitch, make sure that the end of the sling is completely clear of the choker to avoid damaging the sling. And if you use hooks for choker hitches on a load, it is good practice to have the hook openings face outward, away from the direction of pull. This makes it less likely for the hooks to slip off when the slack is taken up. If you are using a wire rope sling in a choker hitch or a basket hitch, you also have to pay attention to load diameter. The load should have a diameter at least 18 times the diameter of the rope. With some larger diameter rope, it may need to be as much as 40 times greater. This is to prevent forcing the sling into a sharp bend. It should wrap around the load easily. Corner buffers on the load protect the sling from being damaged by sharp edges. They also soften the angle of bend to prevent kinking in wire rope slings. Slings and other rigging equipment are always under less stress with a wider load angle. You can increase the angle between the sling and the load by using longer slings. With a spreader bar, or with two hoists working in tandem, you can keep the load angles closer to 90 degrees. Maintaining a wide load angle is especially important when you are using synthetic web or wire mesh slings in a double basket hitch. If the load angle is small, extra stress is put on the outside edges of the slings, and the full width of the sling will not be bearing the load. Now, we've seen how important knowing the size of a load angle can be. So before we're through, let me point out one more thing that sometimes gets people into difficulty. Some load rating tables include sling capacities at 30 degree, 45 degree, and 60 degree angles. However, they are not all necessarily referring to the same angle. Some tables list the angle between the sling and the load, but others list the angle of the sling leg to an imaginary vertical line. And some use the angle between two legs of a sling where they come together at the hoist hook. Be sure you understand what kind of angle is meant in the table you are using. If you ever have any question about the safety of your rigging, if you are unsure about the load weight, if you are unsure about the load capacity of your hardware or slings, if you are unsure of the stability of the load, do not perform the lift. It is too easy for something to go wrong. All of your equipment has to be in good condition. It has to be the right size for the job, and it must be used correctly.